Suspension and Steering Systems. Hello folks, welcome to the lecture on suspension and steering systems. In this session, we will delve into the intricacies of suspension and steering systems, focusing on their components, functions, and basic repair techniques. This knowledge is crucial for understanding how vehicles maintain stability and maneuverability. Let's start this informative journey by exploring each system and its respective components. Suspension system components and functions. The suspension system is integral to maintaining vehicle balance, providing comfort, and ensuring safety. Below are the primary components of a suspension system: springs. The springs support the vehicle's weight, absorb shocks from road irregularities, and maintain tire contact with the road surface. Common types include coil springs. These helical springs are widely used in modern passenger vehicles for their compact design and effective damping qualities. Leaf springs, used traditionally in older vehicles and many heavy-duty trucks. These springs consist of several layers of metal bound together. Torsion bars. These use the twisting resistance of a metal bar to provide spring action, commonly found in the front suspension of some vehicles. Shock absorbers, dampers. Shock absorbers control the up and down movement of the springs, preventing excessive bouncing by converting kinetic energy into heat. Types include hydraulic shock absorbers, utilize fluid to dampen motion. Gas-charged shock absorbers, similar to hydraulic but include pressurized gas to reduce aeration and enhance performance. Struts. A strut is a structural component that integrates the function of a shock absorber with a coil spring. Struts support the vehicle's weight and provide damping. Control arms. Control arms connect the whole hub and steering knuckles to the vehicle frame, allowing for controlled movement and alignment. They are pivotal in maintaining wheel alignment during various driving conditions. Stabilizer bar and tie roll bar. This component reduces body roll during cornering by distributing force between wheels, enhancing vehicle stability and handling. Ball joints. Ball joints act as pivot points between the steering knuckles and control arms, facilitating smooth movement and steering. Steering system components and functions. The steering system is responsible for guiding the vehicle's direction, providing control over its path. Key components include steering wheel. The driver's primary interface with the steering system, translating driver inputs into mechanical motion. Steering column. This connects the steering wheel to the steering gear, transmitting rotational force. Modern columns may include collapsible sections or electric motors for adjustable steering. Steering gearbox. The gearbox converts the steering wheel's rotation into lateral movement of the vehicle's wheels. Types include rack and pinion, common in passenger cars, offering direct steering feel and precision. Recirculating ball, often used in trucks and larger vehicles for robustness. Tie rods connect the steering gear to the steering knuckles, enabling wheel rotation as the driver turns the steering wheel. Power steering system reduces the effort required by the driver to turn the steering wheel through hydraulic or electric assistance mechanisms. Basic suspension and steering system repair techniques. Understanding basic repair techniques can prepare you for addressing common issues within suspension and steering systems. Here are some fundamental approaches: inspection and diagnosis. Regular inspections can help identify issues early. Look for signs of wear such as uneven tire wear, vibrations, misalignment, or unusual noises. Use diagnostic tools and visual checks to determine faulty components. Replacing shock absorbers and struts. Over time, shock absorbers and struts wear out. To replace them, secure the vehicle, remove the old parts, and install new ones, ensuring correct fitment and torque specifications. Wheel alignment. Misalignment can lead to handling issues and uneven tire wear. Proper alignment should be done using specialized equipment, adjusting camber, caster, and toe settings according to manufacturer specifications. Ball joint and control arm replacement. Worn ball joints and control arms affect steering and suspension performance. Replacement involves removing the worn parts, often requiring special tools, and installing new components with precise alignment. Steering gear and power steering maintenance. Check the steering gear for leaks or play. Power steering systems may require fluid changes, leak repairs, or pump replacements to maintain effectiveness. Tie rod end replacement. Loose or damaged tie rod ends can cause steering issues. Replacing them involves detaching the outer tie rod end, aligning the new part, and securing it to manufacturer specifications. Executive summary. Here's a summary of suspension and steering systems. Suspension system 1. Purpose: absorbs bumps, maintains vehicle stability, and ensures tire contact with the road. 2. Components: springs, shock absorbers, struts, control arms, and bushings. 3. Types: dependent suspension live axle, independent suspension coil springs, McPherson struts, and semi-independent suspension twist beam axle. 4. Functions: supports vehicle weight, maintains ride height, and controls wheel movement. Steering system 1. Purpose: transfers driver input to direct vehicle movement. 2. Components: steering column, steering gear, tie rods, and steering knuckles. 3. Types: rack and pinion steering, recirculating ball steering, and power steering. 4. Functions: converts rotary motion to linear motion, provides directional control, and assists with steering effort. Key considerations: 1. Ride comfort. Suspension system affects vehicle ride comfort and stability. 2. Handling. Steering system impacts vehicle handling and responsiveness. 3. Safety. Properly functioning suspension and steering systems are critical for safe vehicle operation. 4. Maintenance. Regular maintenance, such as checking and replacing worn components, is essential for optimal performance. Common issues. 1. Worn or loose components can cause uneven tire wear, reduced handling, and decreased safety. 2. Misaligned wheels affects vehicle stability, handling, and tire wear. 3. Power steering leaks can cause reduced steering assist, increased steering effort, and potential system failure. 4. Springs and shock absorbers, worn or damaged components can compromise ride comfort and vehicle stability. Here's a summary of steering system components and functions. Steering system components. 1. Steering column connects steering wheel to steering gear, transferring rotational motion. 2. Steering gear converts rotational motion to linear motion, amplifying driver input. 3. Tie rods connect steering gear to steering knuckles, transferring linear motion. 4. Steering knuckles attach to front wheels, converting linear motion to rotational motion. 5. Power steering pump provides hydraulic pressure to assist steering effort in power steering systems. 6. Power steering rack houses power steering pump and provides additional steering assist in power steering systems. Steering system functions. 1. Directional control transfers driver input to direct vehicle movement. 2. Steering assist provides additional force to reduce steering effort in power steering systems. 3. Self-alignment returns wheels to center position after turning. 4. Stability maintains vehicle stability and control during steering maneuvers. 5. Responsiveness provides immediate response to driver input, ensuring precise control. Key considerations: 1. Steering ratio affects vehicle responsiveness and handling. 2. Steering effort impacts driver comfort and control. 3. Power steering fluid requires regular checks and maintenance to ensure optimal performance. 4. Component wear. Regular inspections and maintenance are crucial to prevent premature wear and ensure safe operation. Here's a summary of the ball joint and control arm replacement. Ball joint replacement. 1. Purpose: ball joints connect the control arm to the steering knuckle, allowing for smooth suspension movement. 2. Symptoms of wear: clunking or rattling noises, loose or uneven steering, and uneven tire wear. 3. Replacement procedure: 1. Raise the vehicle and remove the wheel. 2. Disconnect the control arm from the steering knuckle. 3. Remove the old ball joint and install the new one. 4. Reconnect the control arm and steering knuckle. 5. Lower the vehicle and tighten the ball joint nut. 4. Tips and precautions: use a ball joint press to avoid damaging the control arm or steering knuckle. Control arm replacement. 1. Purpose: control arms connect the frame to the steering knuckle, maintaining proper suspension geometry. 2. Symptoms of wear: clunking or rattling noises, loose or uneven steering, and uneven tire wear. 3. Replacement procedure: 1. Raise the vehicle and remove the wheel. 2. Disconnect the control arm from the frame and steering knuckle. 3. Remove the old control arm and install the new one. 4. Reconnect the control arm to the frame and steering knuckle. 5. Lower the vehicle and tighten the control arm bolts. 4. Tips and precautions: use a torque wrench to ensure proper tightening of the control arm bolts. General tips and precautions. 1. Wheel alignment: perform a wheel alignment after replacing ball joints or control arms to ensure proper suspension geometry. 2. Tightening sequence: follow the recommended tightening sequence to avoid damaging surrounding components. 3. Inspect surrounding components. Inspect surrounding components, such as the steering knuckle and frame, for signs of wear or damage. Conclusion: understanding suspension and steering systems is essential for vehicle maintenance and safety. By learning about their components, functions, and basic repair techniques, you can ensure your vehicle remains stable, controllable, and comfortable. Regular maintenance and timely repairs will contribute to the longevity and reliability of both systems. Thank you for participating in this lesson. Keep these concepts in mind as you continue studying vehicle dynamics and maintenance strategies. See you in the next lecture. Happy learning, folks!